Hey everybody, this is Larry. This is me trying to do an extra problem, get my money's worth on premium. So, yeah, how do I do this? I always forget every time. Yeah, let's do a random RNG problem that I haven't done before, so we'll be fair. It's 6:34, find the derangement of an array. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So derangement is actually kind of hard in general. The first thing that we notice is the mod, so let's do the mod. I actually don't I know that there's a DP, and given that we have mod and counting, we are going to have to, figure it out anyway. I actually don't remember how to do it, but I just remember that derangement is kind of hard. So that's, well, a thing that we have to consider. But yeah, it's basically no element appears in this, right? So, But I would also say that this is kind of a literature problem because this is actually very well studied and very well understood. Though I don't know why this is a medium, though. I mean, I guess maybe for that reason it is, but it's really not easy unless you've done it before. So, okay. So let's think about it, right? So, okay. I think the thing I would try to think about is try to think about states, right? So what would be the states? The state is going to be, I mean, ideally we want the numbers left, but then we have to kind of try to code how to do it, right? I think that also the other way of thinking about it possibly is count the number of ways that at least one element is in its place. I'm not sure that that's easier, right? I mean, in a weird way, I guess you can sum that sequence easier because I don't know if that's true, to be honest. But basically, you have number of things where only one exact way. No, but then that's a little bit tricky, right? Because you have only one exact thing that is in the original array. That means that you basically have to, like you have one thing and then it becomes like a DP type thing, right? And then you just kind of like, I don't know. I mean, it's fine. I think it just that it becomes n squared. I actually don't know. I don't remember how to do it. I just remember it was hard the last time I did it, which might have been like decades ago. Which but okay. I mean, but the idea is here for a dynamic programming solution. I don't think there's I think the tricky part about this one is that it has like it grows in such a weird way that there's no easy formula, but maybe I'm wrong. So let's think about this one. This may take a while. And again, this is a very well studied form. So if you actually want like an explanation and proofs and stuff like that, I would advocate just Googling it, to be frank. Derangement is a very popular thing. It comes up in random places in real life, which is why it is well studied. But that said, if you really want to watch an idiot, me, to try to see how to come up with this from scratch, then you're at the right place. Okay, so I mean, if n is equal to 1, we have 0, right? And I'm just going to convert this to big N. Then we have 0. And then let's say now we have 2. How do we get to look at one at a time, right? Basically, okay. So the first one has one choice, and the second one has one choice. Okay, but that's like trivial, so I don't know how to. Yeah. Okay, so. But with 3, it gets a little bit funky, right? Because 3, there are like, okay, so the 1 has to go in 2 or 3, so there are 2 choices for the first one. And then, but then there are some consequences. Because if you go to the 2, then the 2 has to, well, it has to go to the 3. I mean, it could try to go to the 1, but then the 3 would match. So I don't know how to represent that in terms of states. I mean, at least not in a reasonable kind of way. The way that, like bitmask is not very useful because the ends are pretty big, right? Can I? The way that the thing that I'm trying to think is how can I get subproblems out of this, right? So, okay, so you have n numbers. The first number. So I guess the two things, maybe, which is whether I see, maybe, right? Okay. I don't know if this is true, but we'll see, right? Okay, so basically if you have n things, okay, so you have to kick off with the first item, right? So the first item, it has to choose something that's not itself. There's going to be n times. And then now the second item, it either, so it cannot choose itself for obvious reason, but it can choose to end a previous cycle or begin a new cycle, right? What happens if it begins a new cycle? If it closes a previous cycle, then that's just, then now you get the recursion of the next number. But if you don't close a cycle, then you have a new thing. If you don't close a cycle, what happens? Well, okay, instead of thinking too abstractly, let's just play with numbers, right? So we have 1, 2, 3, 4, 5. So then now let's just say 1, we put it on the second slide, and then now 2, we can choose to close it, and then that of course is just a, now you have n minus 3 or whatever it is, n minus 2 rather, so you have 3 left. But then the other thing you can do is just choose something else. And what happens when you choose something else? When you choose something else, that means that now, I guess you don't create a new cycle. You just kind of continue the cycle. So that means that you always have two things. You have one cycle and then you have the other thing, right? And then now 3, what happens? I guess that's the tricky part, right? But then here, for all, like you could kind of relabel them, right? Because here, let's just say we select 4, but that is actually equivalent to the next number being 4. Right, so you can actually, in theory, swap this and 3, and this is 4, and it'll be the same state. You have to count the number of things, but then that means that this is an unclosed thing, and then yeah. So you have 2 choices between everything. You have closed and unclosed. Okay, I think that maybe makes sense. That's. I mean, I'm just going to write it out a little bit. We'll see if this actually is good. To be honest, I don't know that it is. Right. So then now, and I might need an extra boolean or something, I don't know. But yeah. Well, I mean, or just like another thing, right? So here, count no cycles, right? So here, and then now the no cycles, and you have to begin one because you can't choose yourself. So there's, if there are n numbers left, there are n minus 1 way of choosing a new cycle. So the answer is going to be this times count cycles, or count with cycles maybe, or with cycle, I suppose. No cycles. But now with n minus 1 number, so then we can kind of return this, right? That's the only choice. You have no, and then count with cycle. You have 2 choices, right? You could, let's see, what is the base case? If you have a cycle and with n is 1 left, then that's it, right? You have no choice, but that's good. You have 1 because there's only 1 place to put it. And then otherwise, you could end the cycle, which is So there's only one way to end the cycle, which is the number that's missing. So it's going to be 1 times count no cycles n minus 1, because now there's, okay, yeah. So that's that. End cycle. And then the other thing is beginning, or not beginning, but continue to the cycle. So yeah, continue cycle is equal to really any other number, right? So that's just going to be n minus 1. And this is the cycle thing is a little bit weird, but it's weird phrasing. I'm thinking, so the reason why I say cycle is because I'm thinking in terms of permutation cycle. Another way to think about this is actually that your seat is taken, if you will, right? Because if your seat is taken, then you have to take a random someone else's seat, and here you can take your own seat. I think that's basically the idea. Okay, so then continuous cycle is just this, right? Count with cycle and then n minus 1. Yeah, and then now we can return end cycle plus continuous cycle. Yeah, I mean we have to do some math, but I just want to see like how I just want to see if this at least gives me roughly the right answer, and we have to of course do memorization and stuff like that. But it looks good for these. Well, I mean these are very silly base cases, so we have to, I don't know. I don't want to go too big because this does grow exponentially. So this should give us a good test. And this looks okay, so I think we're in a good place. And of course we have to mod. So let's actually clean this up now that we kind of verify it. That's kind of super hard. I don't know that I explained this solution very well. I would say that though it is kind of hard for a medium. I don't know that this is a medium. Maybe it is. Maybe I just have kind of a weird hang up on this one. That could definitely be a thing. And we don't need this anymore because that's the base case here. So you have this. You want to mod it. Oops. Here you also want to mod it. So okay. And then of course the other thing is that yeah, there are a couple of things you can do. I mean, we kind of did this chat with I did a problem like yesterday, but I don't remember if this was just like RNG because it just seems very coincidental because this is RNG, right? But you can actually, you look at this and you can actually know that this loops back, so we can actually replace this with that, but I'm not going to do that today. I'm just going to be lazy. So let's just add memorization to this. So has, maybe cycles has cache is equal to right? And then we can write something like, yeah, if otherwise, I don't know why I'm writing it like this, but right. And of course, we should do it with this as well. So yeah. Oh, huh. I got confused in naming. Okay, fine. So my computer is a little bit lagging. I have too many windows open, to be honest. Hopefully the video at home is pretty okay. I'm going to do a little bit of lazy copy and paste. Right. And yeah, I do get questions why I do it this way, but I just think it's easier to read when you look at this way, and I hope that you agree. What the psychos cache? What am I doing? I need to fix my mic. I think the way that my setup is just that it's moving over too much. But yeah. Okay, sorry friends. I'm trying to calibrate it, but yeah. All right. Anyway, let's give it a spin. Hopefully I don't have any typos. And now we can try the really big numbers. I think that's close enough. But yeah, that's a little bit sad. Yeah, the reason is because I guess we have 2 of these, and 10 to the 6 is a little bit big. I think there is I mean, we can rewrite these as bottoms up for sure. You can kind of look at how the form is structured, and it's not that hard to make it. But I want to kind of keep it in structure. So let me kind of increase recursion tab. I don't remember this. I have to Google it because it doesn't really come up that much per se. But I mean, it is odd to see a 10 to the 6, but I guess maybe someone's doing it funkily. I don't know, maybe. I guess it doesn't actually matter as long as you don't use it. Yeah, I mean, you know, maybe it's a bit slow. Maybe we have to kind of optimize it, but yeah. So you can definitely kind of, you can definitely make it bottoms up, and once you make it bottoms up, you can actually do this in all one space. I have a video on space optimization. This is relatively easy problem to do that for, and it's good practice. But yeah, yeah, derangement again is a very well studied kind of problem, so definitely read that up. But I think the way that I would think about it is that you kind of separate them into 2 cases. One is with no cycles. I thought you would create multiple cycles, so I think I'm very happy that and that's why sometimes you have to draw out your visualization, because sometimes your visualization in your head is just wrong. At least that happens to me. And actually, this is a thing where, you know, Josh has a DMOJ contest like just last week, or it ended this week or something. I don't know how you describe it, but in the past week, and that was my thing, was that I got stuck. I got stuck spending 20 minutes not debugging something, but just thinking that something wouldn't work, because in my head I kind of worked it out, but my head is just apparently not very correct in some calculations. But as soon as I draw it out right now, I was like, oh wait, what am I doing? This is very easy. This is very obvious. And then, you know, so yeah, definitely draw things out, challenge your assumptions, make sure that, you know, you don't fool yourself, because the easiest person to fool is yourself. Anyway, that's all I have for today. Let me know what you think. I think this is a very cute, interesting thingy. And also, like I said, there's a lot of interesting places where this comes up, so definitely study it a little bit. Or like, if you're into, you know, if you're into math and being a nerd like I am, then definitely you could check that out. But yeah, that's all I have for today. Let me know what you think. Stay good, stay healthy, do good mental health. I'll see you later and take care. Bye-bye.